Good afternoon, everyone who has joined us today from different parts of the country. We have people from India, we have people from North America, and we have people from Europe joining us today. Thank you so much for taking out this time and joining us for this insightful session. Myself, Vaibhav Ajmera, I am from Bosch Mobility Platform and Solutions. We are here today to discuss on the topic which goes from vehicle data to real-time decisions, building data backbone for connected mobility. This webinar is taking place in partnership with one of our partners, Zeliot. I will do a quick introduction with regards to mobility platform and solutions, but before we will be introducing mobility platform and solutions, and then Zeliot team will be taking over the live demo that they have planned for today. Any without wasting much time, let me just get on to quickly of what MPS does and what and who MPS is. So, mobility platform and solutions. We are um, a Bosch entity that is based out of three geographies. We are in India, in North America, and in Europe. As platform and as a platform player, we are a collaborative and innovation platform designed to accelerate transformation in the logistics and mobility ecosystem. We bring together startups, enterprises, technology providers, and industry experts to co create scalable future ready solutions. Our core MPS at our core, MPS focuses on fostering an open, connected environment where innovators like Zeliot and others can experiment, collaborate, and deploy cutting edge ideas across supply chain, transportation, and mobility services. So, today we have one of our innovators on board, that is Zeliot, who is innovating and doing a great job when it comes to the logistics and mobility space. So, without taking much time, I would let Mr. Akshay from the Zeliot team introduce the topic, introduce their product a little, and then get on to the demo of the uh, solution that we are looking at today. Over to you, Akshay.
Yes. Thank you, Vaibhav, for setting that wonderful context. Welcome everyone to this session. Good morning, good afternoon, for people who have joined from across the globe. So, as Vaibhav mentioned, I am representing Zeliot Connected Services today. So, we are a Bosch partner company who have been predominantly working in the connected mobility space, and we have a platform called as Condense. It's a real-time data streaming platform which is specifically targeted towards connected mobility use cases. So when I say connected mobility use cases, it is more to deal with vehicle data that is in motion, and how do you ensure you get that opportunity, or you get that opportunity to act on that data in real time itself. So think of any system which basically has three aspects to it: input, process, and an output, right? So input, and in this specifically in this connected mobility or the vehicle data space, the input is more often than not a telematics device which is installed on the vehicles, and or we could have also APIs which are coming in from the OEMs who are taking that real-time data, or it could be any other database which is storing that data, and we are pulling that, and the data is being pushed to downstream part, right? And in the middleware, where a lot of your processing of the data, the management of the data, normalization, orchestration, aggregation, all of that is expected to happen. That is where a platform like Condense comes in, and it is deployed on the customer's cloud itself for all of the data to get ingested. And then you bring in your own business logic, you write rules on the real-time data set, and ensure that business logic is then pushed to your downstream application. And when I say downstream application, it could be a typical fleet management solution, it could be a driver mobile application, or it could be a DB where you're just persisting the data to for future analysis, or it could be an API endpoint where this data is being pushed for further software integration, or it could just be a simple SMS or an email or a WhatsApp gateway where alerts are being triggered on the real-time data, right? So this in this entire data journey, the middleware is where our platform Condense sits. So for us to get the data from the data source, and then manage this entire data and enable the output of that data into downstream applications. So this, in a nutshell, is what we do. That is where the Condense platform takes its fit. And coming to the kind of use cases that we are solving, we predominantly again work with vehicle manufacturers across the globe. So we currently manage about 600,000 plus vehicle across various deployments in India and the European and the North American region as well. So with this quick introduction, I'll now bring up the deck, which will spend about 5 to 7 minutes on quickly explaining what the product is about, and then we'll jump into the actual product demo, where I have my colleague Rakesh, who will be supporting us in creating an entire data pipeline, while I'll be explaining the overall activity. So this data pipeline is about how we ingest the data from a real-time vehicle source, what are the kind of transformation or real-time rules that we write on this data set, and how do you output into an output connector or a sync connector that we typically call, or a store connector that we typically call. So this is what we will go through. Please feel free to raise your hands and pose any questions, or we could take it in the last section of the session as well. Right. So I'll just bring up my screen now. I hope my screen is all visible.
Yes, it is visible.
Great, thank you. Right. So our this is what we in a single line streamlining data apps with Condense. So, but our topic for today is say vehicle data to real time decisions. That's what we are here to talk about. A quick intro about what all we have been doing. So like I said in the beginning, Bosch is we are a partner company of Bosch, and also Bosch India is an investor with Zeliot. So our deployment of the product typically happens through the cloud marketplaces. So we are live, we are available on the major three cloud marketplaces: AWS, GCP, and Azure. So depending on wherever the connected vehicle platform of the customer or the use cases of vehicle data is being run, on that particular cloud, we are flexible to deploy the product. So these are the kind of customers that we are globally working with. So the majorly listed here are the Indian customers. One is from the European region. We work with Volvo. We work with Royal Enfield, which is a global two-wheeler manufacturer. We work with Eicher, who's a commercial vehicle manufacturer, TVS Motors, Ampere, and so on. And some metrics on what the Condense platform has been capable enough to deliver. We are currently managing a throughput of close to 1 Gbps and promise an uptime of 99.95%. That's the kind of SLA we meet. So it's an enterprise grade platform that we offer. We are a team of around 110 people based out of Bangalore and India. And in the last calendar year, we have processed close to 5,000 TB of data. Right. So let's take a minute to understand what the platform is. So this is a data streaming platform, of course, integrated with an agentic AI kind of a framework as well, where you can, based on the personal prompts or the user prompts, you can have this entire data pipeline created. So that data pipeline is again taking this data from a source, enriching that data using the transformation layer, then outputting that data to a downstream application. So this seems a simple activity, but that is where the engineering complexity as well comes in. So taking a top-down approach here, you have different sources of data. For vehicle data, like I said in the beginning, it could be APIs from the OEMs which are sending us the data, or it could be telematics gateways which are installed on the vehicle architecture giving out the data. Then you have a platform like Condense deployed on the customer's cloud, which comes in with a transformation layer, and that utility, that module is called as a low-code, no-code utility, using which you can write your real-time rules and then output that data to downstream applications. It could be DBs or just an API or a webhook endpoint that is taking the data. Right, and this layer is where we bring in that code repository integrations as well. So when I say code repositories, it has got to do with your GitLabs or GitHubs or Bitbuckets, where your custom transformation or the logic that you want to build on that raw data is going to be deployed on the platform as a Docker image, and using this Docker image, you're going to enrich the data. And of course, I touched upon the tech layer part, and this is where the streaming foundation and the underlying technology on which this platform is built is Kafka. So Kafka is that message queue system which helps us manage high throughput data, which is relevant for use cases like that of a vehicle data, where typically the data transmission happens anywhere between 100 milliseconds up to 10 seconds as well. And it's a huge payload. It's just not the GPS or the location data that we typically get access to, but it also has the vehicle architecture data where you have to write a bunch of rules to understand the overall behavior of the vehicle, the way it is being utilized, the way it is being operationalized in the real time itself. So that's where the product fit is found for the vehicle data use cases. Right. So this is again the system part which I touched upon. So on the left hand side, you see a bunch of connectors which are onboarded as pre-built connectors, but we also give that flexibility to customers to write their own transforms. I mean, bring in their own connectors, and then this mid layer is where you get to enrich the data using our transformation framework, and this is the output connectors. You can again use the pre-built connectors available on the platform, or bring in your own connector based on how you want to utilize that data. So this is an example of a recent commercial vehicle OEM that with three-wheeler manufacturer that we onboarded here in India. So before using Condense, this was a kind of data complexity that they had, where there were at least 5 to 6 different data hops before it actually powered the fleet management solution. And that was leading to a lot of latency and also additional costs on the cloud because of different networking that was happening. Because the data hub was again happening from one cloud to another, which are deployed across different geographies or different regions as well. And by positioning Condense, which was that unified backend layer for the entire vehicle data, we were able to bring down the data hub to only 3 from 6 data hubs. And all of the data set was again localized within the Indian region, which is called as APAC South here in India. And with this deployment, we were able to achieve a total reduction of up to 48% in the total cost of ownership. So this was the kind of impact that we were able to bring in for that particular OEM. So you see this is the complex pipeline which they were managing before, and this is how it was simplified on using Condense. And this is what we will actually showcase during our actual product demo, where a real-time streaming pipeline will be built on the incoming vehicle data, right? And how do we simplify this? So I mentioned in the previous slide, we are here to simplify your existing data pipeline. So how is that we simplify is what I would want to touch upon now. So again, streaming data, you have all of your multiple sources that are coming in. And once you have that streaming data, you'll have to have a mix and match, a culmination of all of these different tools and technologies that are required to manage a platform, a real-time data streaming platform for the connected vehicle use case, connected vehicle platform use case. So you need a lot of your network interfaces, which you have to onboard. So this is typically your protocols in which the data source is generating the data. If you guys are aware about protocols like MQTT, HTTP, TCP, so these are the kind of protocols that you need to put effort on integrating. Then, of course, depending on the frequency and the kind of throughput you're expected to manage, you need to have a message queue system like a Kafka, like Kafka, how we are using Kafka, a similar message queue system to be self-managed. And you need to have your multiple microservices required to power your analytical dashboards. And then, of course, for the databases that you will have to do, depending on what type of data, time series data, caching data, and all of that, you have to bring in the right databases. Then, of course, the hyperscaler that you are required to manage and to monitor and observe the performance and the utilization of all of these different tools, you need an observability layer as well, like a Grafana or a Prometheus, right? So a culmination of all of this is required, and all of this could be offered in a single black box called as Condense. So the engineering heavy lifting or the overall headache with respect to integration of these protocols, managing the data, scaling the infrastructure depending on the data volume, depending on the kind of throughput that is expected to be managed, that is something we completely offer as a package, as a managed offering, so that the OEM or the enterprise who is actually expected to utilize the process data can have complete control on the outcome of that data set, so that they could focus on the solutions that they are expected to build on that data, It could be a flat fleet management solution. It could be a driver app. That example that I took off in the beginning of the session, right? So they get complete control on their reporting and dashboards. So this middleware layer is completely where we offer it as a single black box, single packaged solution. That's what Condense essentially does, right? Some metrics on what are the kind of benefits that we could pass on to customers. We could bring in a higher throughput of up to 25% based on your existing pipeline mechanism that you're using. In terms of TCO, total cost of ownership, in a period of 3 years, we could bring in close to 40% of savings. And of course, from a business standpoint, in today's world where every other day there's a new change or a new deployment that is happening, GTM plays a very critical part. So that's where instead of you spending that engineering effort in integrating and maintaining and managing all of this, on day one, we make your use case of vehicle data to be enabled and market ready, right? So that's where we promise a 50% faster GTM as well, because we have already spent time and effort on integrating these connectors which are required to handle all this vehicle data. And we extend this to also called something called as a marketplace, where third party builders can come and deploy their own connectors or transforms. You as a user of Condense can bring your own transform, and Zeliot in the backend is always developing those connectors, which will be again through the marketplace. So this is what I wanted to touch on Condense. And the last part is, of course, the deployment methodology. So Condense is a product which is very data sensitive because it is managing more often than not IP data, personal information, and all of that. And in a vehicle data scenario where we have a lot of vehicle architecture related data, CAN related data, ECU related data that is coming in, which is IP of the customer, it becomes even more sensitive. So it is not a typical third party SaaS kind of offering where the data is going to a third party cloud and I have access to all of this data. Condense is deployed through the cloud or the hyperscaler marketplace on the customer's tenant itself. So the entire data residency, data sovereignty, all of these clauses, all of these expectations are already met. And of course, it extends to compliance as well with respect to GDPR, DPDP here in India, or SOC 2 compliance that are expected from a data platform. And one last point that I want to touch upon before we close on the deck is on the pricing. So it's a transparent way of providing the pricing where the model is purely based on consumption. So consumption is with respect to what is the kind of compute that happens with the incoming data. It's not a fixed pricing like how a third-party SaaS application is provided, and irrespective of your vehicle usage or data that is getting managed, you still have to pay for that application, right? So it's not a typical way. It is purely dependent on some minimal compute that is expected and the throughput that is managed in a calendar month. So that's where the pricing methodology as well comes in. Right, great. So with this intro on the product, I would now like to invite my colleague Rakesh, who will be actually talking about the product part where we start building the real-time pipeline. But before that, I'll just touch upon one point on how the deployment usually happens. So this is where, so I was talking about the marketplace deployment, right? So this is a use case I'm showcasing on the AWS marketplace where the product is live. So you go to AWS marketplace, look for the product Condense. You click on view purchase options. It's a 30 to 40-minute process of deployment that happens. So the admin credentials are provided and and a cluster is spawned off where the Condense platform gets deployed on the customer's AWS tenant. So once this happens, we get access to something called as a console. So there are two parts to the product. One is called a console, where we actually create different environments that are required for the user to manage their data pipeline use case. So here I am already assigned to an environment called as demo.condense. That is where we will be actually building the pipeline. So you can consider this console as that super admin or that admin portal where you're actually inviting members, creating environments for the use cases of your data streaming to be actually built. And then once those environments are created, you can have a box called as a workspace, within which you build a specific use case or create your data pipeline. And that is where Rakesh will now come in, right? Right. So this is the landing page. So I used a word called workspace, right? So that workspace, these are the boxes which are called as workspaces. So each workspace is where you're defining a data pipeline use case, right? And for today's demo, we have a workspace created called as webinar 24/4. So once we click on this workspace, it will be empty because we have no data pipeline created. And this data pipeline is nothing but we are expected to ingest the data from a data source, then enrich or transform that data, and then output it to a destination, right? So what we're going to showcase today is we have connectors from OEMs like Volvo and MAN Trucks. So these APIs, the OEM APIs are already onboarded as connectors onto Condense. So now the data pipeline that we are going to create is using these APIs as the source data. I'm going to get some real-time data with respect to different VINs or different vehicle IDs. And we will be selecting one parameter on which we'll be creating that enrichment of the on that entire raw data. And that enrichment is going to be connected to our output destination using the alerting mechanism on that real-time data itself. And this output destination that we are going to showcase today is a Teams notifier. So all of us who are on the Outlook ecosystem will be well versed with Microsoft Teams. So how do you get this data from an OEM API, do that enrichment layer, and throw that alert on a parameter that I'm acting into a Teams notifier? That's what we will be showcasing. Rakesh will just stop sharing because it's sensitive data with respect to the client ID and client secret here. Give us 10 seconds, please. This page, what you're seeing is called, sorry. This is where we are expected to input some environment variables for us to start getting in the vehicle data. So these are three basic input fields that are required, which we usually get access from the OEM itself. So now what we're trying to do is get this data from Volvo trucks. So Volvo Connect is the API that which is onboarded here on Condense as the connector. So by inputting these fields, if you can see here in the bottom of the page, where we have different VINs which are selected. VINs are nothing but vehicle identification numbers, which are giving us the data from all of these OEM API, right? So this is where it is. So now what we are going to do, we are selecting all the VINs, or you also have the flexibility to select a particular VIN if you want to create your enrichment or transformation only on a particular VIN. So this use case, let us select all the VINs. Then we'll have to do some configurations on that. So this is basically defining the polling frequency that we want the data to come on to Condense. Then how do you want to output that? So like I said in the beginning, this platform is based on a technology called Kafka. With Kafka as the data pipeline builder or the underlying technology, we have something called as topics. So these topics are, they use a mechanism called as producer consumer. So there is a topic which is getting the data from a source, and it has also to publish the data to a different source. So that intermediate connection between two different sources is the topic. So here, for the sake of the webinar, we have a topic created called as webinar_1_24. So now all of this data of these VINs that are selected here will be talking to this topic. So once we deploy the connector, you can see the actual data pipeline taking shape. Right. So previous to this, we did not have anything here in the data pipeline. So this box you see is now ingesting the data from the Volvo API connector from all the VINs at a defined frequency. So now we just defined this frequency, got into the connector, clicked on the logs, and now we should be able to see some logs here. Right. So right. So you see here total records sent to this Kafka topic are 101. So these are the number of messages which are being put onto this particular topic. So what is the message structure? What are the different kinds of fields that it consists of? To check that, we come to the Kafka management tab. We go to the Kafka topic, select that particular topic, then look at this message by giving the offset and other parameters related to the particular topic. Right. So this is the typical message format that you see we are getting here. So if you see, there is created date and time. There are parameters such as GNSS position. There is location coordinates with respect to your lat long, the direction in which it is heading in terms of degrees, what is the altitude, what is the speed at this point in time, and so on and so forth. Right. So we will be now selecting, say, speed as a parameter, for example. So at this point in time, let us assume a use case where there are 50,000 plus vehicles which are talking to the platform concurrently. And at this point in time, I want an alert on all those vehicle data sets, say, which are moving at a speed of greater than, say, 50 kilometer per hour or 50 miles per hour, for example. So how do I do this in the data pipeline? So I have the raw data which is coming in from the vehicle OEM API, which is onboarded here as a connector. Then I have defined this message structure. So now what I'm going to do here is simplify this entire data set, take speed as one parameter on which I'm going to write a rule, and then output it to my Teams notifier. This is what the pipeline would now look like. So now, yeah. Right. So we will also bring in a different connector because the platform is capable to each pipeline or the platform in general is capable to handle different source connectors as well. So this Rio is a connector from a manufacturer called Mantrax. So again, we will have to input these details. We'll just bring down the screen for a moment. So here, what you're typically seeing is Condense is being positioned as that unified backend platform where data from different sources or multiple sources is being clubbed into a single one. So if at all in a regular scenario, if I'm a fleet operator who has a multi-fleet and a combination of both, say, MAN trucks and Volvo trucks, and I'm talking independently to each of these OEMs will obviously give me the API access. But this API should be again given to different software solution providers. They'll have to put that effort and integration and all of that. And then also representation, you will have to again downstream it to different application the way you want to control it. So you see the number of data hops and the kind of operational or the procedure delays that you see in this entire SOP. So instead of that, position Condense as that backend platform where we have this unification of data sets from multiple sources, and then we downstream it to the required output. So now we have the required fields created for Mantrax as well, which is called as a Rio connector. So I have a demo when here, demo vehicle, which is sending me the data. So we are similarly, like we defined in the previous step, we are defining the source of the data, we are defining the pulling frequency and the topic to which this data has to be published onto. So it's again the topic that we selected. Yes. So now you see we have two different source of connectors or sources of data already onboarded. We will again see a message sample here on this particular topic. Yeah. So we have a different data set. So this data set, if you see here, it's not the same set of parameters which were coming in the Volvo API. So here there are some overlapping parameters, of course, but there are some additional as well. So you see wheel speed, which is coming here, engine speed that's coming here. There is an ignition related status, there is a device ID, and so on and so forth. There are multiple parameters. But for us, one overlapping parameter we have in both the data sets is the speed. So now what I'm going to do is give better shape to this entire pipeline where I'm going to act on speed as one parameter, create an alerting mechanism using my transformation layer. So now we have both of the sources onboarded. So now I go on to the feature where I want to write a transform or to enrich this data set. So I'm using my utilities module to create this entire alert. And since we already have a topic onto which this source data is being published onto, I'm reading the data from that particular topic. So there is a JSON format in which the data is now being saved. Then I'm now creating this transform using the utility module, and I'm naming this transform as overspeed. Overspeed is because on the incoming speed value, I'm writing a rule defining a speed value and beyond which I want an alert to be generated. Right, and this is going to be published onto a different topic. So we have webinar 1 and 2 as my source connector topics which are publishing the data. Then put together, we will combine, culminate this entire data and put it into a topic called as webinar _3. We have defined the topic onto which the data needs to be hopped onto. Now I'm writing the rule. So I'm selecting speed here, select condition type greater than. So this is a low code, no code way. So it could be a non-technical user sometimes who's using Condense as a platform. It could be people from the command center or uptime center. It could be operations guys who are monitoring the vehicle performance, right? So it is not always a developer persona who's acting on the data set or doing some analysis on the data set. So to keep it friendly for all types of personas, the low code, no code utility makes a lot of sense. So now we have defined the rule on that typical speed data set where I've said consider the speed as a parameter coming in from both of these data sources and throw me an alert and give me the vehicle IDs which are having a speed of greater than 60 miles per hour. Right? So now I'm writing a custom JSON on how this output data has to be. So this is how my alert will look like for Volvo truck overspeed has been detected on so and so vehicle ID, and then the value also will be associated with it. So that's the final alert or the output that we get, which we can see on our Teams notifier. Right. So now the pipeline is taking shape. We have the transformation as well that has come into the pipeline. So we did this for the Volvo trucks API. We are replicating this activity for the Rio connector as well. Yeah. So this is a log from the demo vehicle that we have onboarded for the Rio connector. So we will just take this data set, bring it into a JSON format that we want, and again define the metadata, which is again the speed as a parameter now. So we again go to add it as a transform, use the alert utility, read it from a topic, which is the webinar _2 topic, where the data was initially being published. Yeah, so here what you also say is the flexibility for you to actually edit the JSON as well. So if there are some junk values or some parameters which you actually do not need as a part of your JSON validation, you can just remove those and then get the JSON validated and then take down your metadata as well. Yes, so now this particular JSON is validated. So I'm entering the details required for me to stream this particular data set. So it is being called as overspeeding on the Rio connector or the MAN trucks data that I'm getting. So I'm publishing this as well to the same topic, webinar _3. So you see here, there are two different source of connectors. Both the sources were initially talking to two different topics. Volvo was talking to webinar _1 and the Rio connector was talking to webinar _2. But now from two different sources which were talking to two different topics, I'm taking the entire data set, unifying that into a single metadata called as overspeed and publishing that to again a unified topic called as webinar _3, right? So that's where the complete simplification of the data pipeline comes into a picture. So you're avoiding a lot of your data hops. The data is residing within the system. It's not going out. You're able to bring in multiple sources of data, act on that data in real time itself. So all of this activity, by the way, is happening on the real-time data set. And the alert that you get is also on the streaming data from the vehicle at this point in time. Right, so I'm defining the structure in which my alert needs to be triggered for the Rio connector. So in the bottom, you see there is a metadata created for the MAN overspeed. So I'm going to now deploy this utility as well. Right. So now this entire data pipeline is in a way complete. So we have the source and the transformation already in place. We just have to now connect this to an output or a destination. So like I mentioned at the beginning, we will be using Teams notifier as our output destination. Yeah, and this is one more part that we will quickly touch upon. So if it's a developer-centric organization or a developer who is trying to write rules on this, we also have an IDE built in with the integration of a Visual Studio Code editor that comes in where the user can connect their own code repository like a GitHub or a GitLab or a Bitbucket, then respective repository and their branches where the code or the transform can be deployed as a Docker image. So if you're not interested in the low code, no code way of doing things, if you want it to be for a larger data set, you can have your code deployed and that runs as a transformation as well. So that is what we are doing for the Teams notifier here. So now I'm selecting this as an output connector because the transformation is already done in the low code, no code way. Depending on where you're bringing in your transform, whether it's your actual transformation layer or an output connector, you can select it from the drop down. So I give it a version name and I just define what this connector is actually doing. So this is basically giving me overspeed detection or alert as a notification for the source data of both Volvo truck and MAN truck. So this is now in the backend validating the details with respect to your user permissions, connection of your code repository, and the respective repository and the branch mapping as well. So now comes in your ID part where you can actually use the code to develop and deploy the transform. So we call this as environment variables. So we'll have to define because it's a Kafka pipeline where there are multiple sources, multiple topics from which we are taking the data from and publishing it onto. So these environment variables are being now defined. Right. So today, what we are now doing is publishing this onto a Teams notifier. So this could also be your output connector. Could also be say a database where you want to just process the data for future analysis. It could be an API endpoint. It could be some other Kafka system to which you are publishing this data as well, right? So the source data is again coming into the first Kafka topic, and you are publishing the process data onto a different Kafka topic where the consumer or the end user might be using it for a different application. So now all the environment variables are input has been provided. We are now building the application. So this we are just giving the name to this particular Docker image. So I have this entire code from my code repository embedded into this transformation layer here. So this will take say 20-30 seconds to build, and now your complete pipeline would be ready. Right. So the entire Docker image has now been built. So we are now publishing the application. So under the connectors section, we are now segregating or filtering the custom connector that we just created. So you see here this Teams notification or the Teams notifier connector that we just created is now live. I'm now trying to or rather consuming this to complete my entire data pipeline. So my source is ready, my transformation is layer is ready, and the kind of alert that I want to be run on the transformation layer, that also is ready, where we selected speed as a parameter. Now I want this to be outputted onto my Teams notifier, right? So that's where this entire configuration is now being done. Yeah, we'll just bring down the screen for a moment. Yeah, right. So now the pipeline is complete. So again, summarizing, this left-hand side you see is the source part, this is the transformation layer, and this is the Teams notifier onto which I'm outputting the alert data. So let's go inside and try and see if the logs are actually being generated, or we could actually open our Teams itself. Right. So I have a channel created on my Teams called as Webinar Speed Alert. So I have this entire data set that is coming in. So you see this data set which is getting generated in real time. Right? So it says overspeed is detected, what is the type of trigger, what is the vehicle ID on which this overspeed is detected, and with respect to what all other parameters, at what is the location, what was the direction that it was at, what was the altitude the vehicle was being driven, what is the actual speed. So if you see all the speed values here would be more than the threshold. So you see here the vehicle base speed. So it's 61, 71, and so on. So we have defined the value to be more than 60, and an alert is generated only when that particular threshold or value is crossed. Right. So we have continuous messages that are coming in. Right. Right. So with this, we complete the entire data pipeline. So this is the type of use cases. The use case that we showcase now is a very simple one, where we just have a couple of sources. We are doing a transformation on only one parameter in that data set and connecting to a simple output called as a Teams notifier. Now assume this to be replicated for a deployment of say 600,000 vehicles, right? So the manufacturer or the enterprise could be using 10 or 15 or 20 different sources of telematics here. All of them are talking to a single unified backend. So we need so many topics to be created, a platform which is capable to handle that humongous amount of data to manage without crashing. If there is a sudden surge of data, the auto-scaling parameters with respect to the infra and the compute are required to kick in so that there is absolutely no downtime. You write transformations on n number of parameters. Today we have written it only on a single parameter. Then you output into again different destinations. So today the simple one was a notifier. It could extend to WhatsApp, email, SMS, database, some of the Kafka system, an API endpoint, an integration with your different applications such as an ERP or a CRM, right? So all of this mix and match or permutation and combination within a data pipeline is possible on the Condense platform, right? So this is what we wanted to showcase during today's session. So I think we are bang on time. We have completed 50 minutes. Let's open it up for questions, please. Thank you, Vaibhav.
Thank you so much, Akshay. This was wonderful. The experiment and everything that you showcased was actually something that is so easy to execute, right? And in today's time, when like time is actually the currency that we are looking at,
Right.
in that if things can move extremely quicker and data can be processed so easily and so quickly, that is something that all the mobility players are looking at. So
Right.
great, thank you so much for your presentation right now. uh, Guys, we are open to take any questions. If you all want to get in touch, maybe you all can write to us. You'll have our email IDs, you'll have our uh, say links to connect with us. Please feel free to get in touch with any of us. Just write to us and we will be available for any conversation, be it physical, be it virtual. All right. Thank you so much. Thank you so much, Zelia team. Thank you so much, everyone, for attending this insightful webinar today. And have a good day, guys. Thank you
Thank
so
you.
much.
Thank you, Kishore.
Thank you.
Thank you, everyone. Good day, all of you.
Thank you.